What's a pulley and what's it made up of? It was made to lift heavy objects from the ground to above. To define a pulley, it's a wheel and an axle designed to support movement and weight moving objects with no hassle. These are parts of the fixed pulley, the simplest of them all. It is fixed to one spot on a floor, ceiling, or a wall. This is the wheel, it spins freely on its axle here, and the rope moves back and forth on the groove on the wheel there. When the effort is forced down with the rope that is attached to the wheel, which now spins and lifts the load in this act. In a fixed pulley, the effort and the load must be at least equal in weight to hold. Here are 3 types of pulleys we will discover now. You just learned about the first one, the fixed pulley, I do vow. The second is called a movable pulley. It is slightly more complex than the fixed pulley you see. The pulley itself is attached to the weight of the load as the effort moves the rope while the rope's attached as shown. The third pulley is complex. It's called the compound pulley. It combines the fixed and the movable pulleys you see. Here's the rope, it's attached to the board above like so, running through the first pulley that's attached to the weight of the load. The rope then moves up through the fixed pulley as shown here. As the effort is pulled, it lifts the load up in the air. The effort of this pulley is half the weight of the load, which makes it easier to pull a heavy load. You should know all these pulleys have a rope, wheel, axle, and a load, as the effort used to lift the load in the air as we have shown. What's a pulley and what's it made up of? It was made to lift heavy objects from the ground to above. Check out the new KLT Geography channel with new videos every Saturday. This is a lever, it's a simple machine made of a fulcrum and a rigid beam. The lever was first brought forth in 260 BCE by Archimedes, the Greek mathematician, that's who you see. This simple machine is made of a rigid beam and a fulcrum, as I mentioned, but what does that mean? First, let's look at the 2 parts of the lever that will be told: the effort input force and the output force, which is the load. These 2 are applied to either end of the beam, just like this, which balances on the fulcrum, the point in which the beam pivots. When an effort is applied to one end of the lever, a load's applied at the other end of the lever. But how's this clever? This moves a mass upward due to torque. Torque's the amount of force required to move this load north. Now, what are the mechanical advantages that I'll imply? It has to do with how much force a simple machine does multiply. The further the effort is away from the fulcrum, the easier the load will move. Here's the lever classes for fun. The first class lever does show the closer the fulcrum is to the load, the less effort is needed to move the load a shorter distance. You know, the second class lever's load's located between the effort and fulcrum. The closer the fulcrum's to the load, the less effort's needed for the outcome. The third class lever's effort's located between the load and the fulcrum. If the fulcrum's closer to the load, then the less effort's needed to move it some. This is a lever, it's a simple machine made of a fulcrum and a rigid beam. The Apollo mission brought humans to the moon. The first flight was in the 1960s. We hope to go back soon. The Apollo missions were a NASA program and set a major spaceflight milestone for all humans. The Apollo program was conceived in 1960 during Dwight D. Eisenhower's presidency. Then the Apollo program started in 1961 and consisted of 11 total space flights and missions. Apollo was a NASA program that had American astronauts. Out of the 11 space flights, 6 of those resulted in moonwalks. The first 4 flights tested the equipment used in the Apollo program to see if astronauts could be sent to the moon and land. Apollo 1 attempted to launch in 1960. landing in the lunar highlands, this mission was done. The first use of the Apollo rover happened in 71 as well. This launched on Apollo 15 mission and it went real swell. Apollo 16 launched in 1972. Astronauts explored the lunar highlands, this is true. In 72, Apollo 17 was launched and nothing went wrong. This marks the last walk on the moon. Since then, no one has gone. You could visit space someday and our Earth you will see. Or you could visit a different planet and make history. The Apollo mission brought humans to the moon. The first flight was in the 1960s. We hope to go back soon. Shop our new store merch and get custom birthday videos with your favorite characters. I'm the ISS, the International Space Station. 1998 was the year that begun my construction. I make multiple orbits around the Earth every day. Let's learn more about my history as we orbit in space. I fly around the world every 90 minutes. I orbit the Earth 16 times in 24 hours, that's legit. I'm 357 feet long from end to end. Am I? After the moon, I'm the second brightest object in your sky. I have 2 bathrooms on board, there's also 1 gym. I have 6 sleeping quarters and 6 spaceship docks for the win. Here's a brief history about how I came to be. Pay attention to my incredible collaborative construction story. The idea of the space station was science fiction until the 1940s. The structure might be built by many nations. In the 1950s, designs of spaceships and space stations began to develop. With the beginning of the space age and it gained traction. The first rudimentary station was created in 1969 by the linking of 2 Russian Soyuz vehicles in line. In 1984, the US President Ronald Reagan told NASA to build the ISS for many nations. Then in 1998, the construction had begun of the only international space station. That year, the first segment of the ISS launched in November 20th by the Russian Proton rocket named Zarya. It's no myth. The Unity node from the US launched December 4th by the Space Shuttle Endeavour, set it on its course. The Endeavour met Zarya in orbit with the Unity node to make the first connection with the Russian segment, you know. In the year 2000, the first crew to man the space shuttle adrift was Bill Shepard, Yuri Gitsenko, and Sergei Krikalev. The US lab module was added in 2001. Then the European and Japanese lab joined in 2008, and we're not done. The ISS consists of 50 nations: Canada, Japan, and the Russian Federation, the United States, and the European Space Agency. They are Belgium, Denmark, France, Germany, and Italy, the Netherlands, Norway, Spain, and Sweden, Switzerland, and the famed United Kingdom. Maybe you will have the chance to visit me someday and be another part of the ISS and its history. I'm the ISS, the International Space Station. 1998 was the year that begun my construction. I make multiple orbits around the Earth every day. Let's learn more about my history as we orbit in space. There are 8 planets in the solar system, and we revolve around the sun. Join us to learn about the different planets. Now sing along and have some fun. My name is Mercury. I'm the second hottest planet, but the closest one to the sun. A year on my surface is 88 days. I'm the smallest but lots of fun. My name is Venus. I'm the hottest planet, but the second planet from the sun. I'm the brightest planet in our solar system. name is Earth. I'm the planet you live on, and the third planet from the sun. I'm the only planet with organic life, so take care of me, 'cause we're all one. There are 8 planets in the solar system, and we revolve around the sun. Join us to learn about the different planets. Now sing along and have some fun. My name is Mars. I am red in color and the 4th planet from the sun. I have the highest mountain in our solar system, a volcano named Olympus Mons. My name is Jupiter. I am covered in clouds and I'm the 5th planet from the sun. My giant red spot is a raging storm. As for size, I'm the biggest one. My name is Saturn. I am brown in color. I'm the 6th planet from the sun. My outer rings are extremely thin. They're made of dust and icy chunks. There are 8 planets in the solar system, and we revolve around the sun. Join us to learn about the different planets. Now sing along and have some fun. My name's Uranus. I am blue in color. I'm the 7th planet from the sun. I orbit the sun once in 84 Earth years and was discovered in 1781. My name is Neptune, also blue in color. I'm the 8th planet from the sun. I'm the last gas giant in our solar system, and I'm also the coldest one. There are 8 planets in the solar system, and we revolve around the sun. Join us to learn about the different planets. Now sing along and have some fun. I am the Milky Way galaxy. Look in the night sky to see a part of me. I am the Milky Way galaxy. Your solar system's just a tiny part of me. The Milky Way name came from a Greek goddess named Hera, who spilled milk across the sky. Greeks believed in that era. When you look at the darkest sky on a clear summer night, and you see the image of the Milky Way clear in sight, remember you can only see a small part of me, called the galactic core in my galaxy. Astronomers can't look at me from outside the galaxy, because I'm so massive and you don't have the technology. Based on other galaxies we see outside of our own, is why we conclude that our galaxy spiraled as I'm shown. When you look at a side view of the Milky Way here, you see me as a flat disk with a bulge center. I appear. I am the Milky Way galaxy. Look in the night sky to see a part of me. I am the Milky Way galaxy. Your solar system's just a tiny part of me. I was born about 13.6 billion years ago. That's a hypothesis given from astronomers, though. I am 100,000 light years in diameter. That's an estimate given by NASA, though they can't be sure. Your solar system's this tiny dot that you see right here. Astronomers think that Orion spurs where your system appears. Your system's guessed to be 25,000 light years from the galactic center of the Milky Way shown here. About 230 million years is what your system takes to orbit around the Milky Way center's cool shape. 200 to 400 billion stars live in me. That's an estimate only based on our astronomy. Over 100 billion planets might exist in me. Maybe someday you can see them in our galaxy. I am the Milky Way galaxy. Look in the night sky to see a part of me. I am the Milky Way galaxy. Your Your solar system's just a tiny part of me. Let's take a look at all the parts that you think I'm made of. We'll start by looking down at the galaxy above. The galactic core's the rotational center you can't see. Because of the interstellar dust, it cannot be studied. It's believed the center is a supermassive black hole. When astronomers find out more, then I will let you know. You'll notice the galactic bar and also the long bar. There's the 3 kpc arms, there is a near and there's a far. Then we have the Sagittarius and the Norma arms. Then the Orion spur, where your solar system spins on. The Scutum Centaurus and Perseus arm are 2 major spirals and full of the galaxy's charm. Finally, the outer arm and the new outer arm are the final spirals I will mention in this song. I am the Milky Way galaxy. Look in the night sky to see a part of me. I am the Milky Way galaxy. Your solar system's just a tiny part of me. I am the Milky Way galaxy. Look in the night sky to see a part of me. I am the Milky Way galaxy. Your solar system's just a tiny part of me. We're all stars compared to each other by size. You can see a lot of us when you look into the night sky. We're all stars, our colors vary, you know. We're made mostly of hydrogen and helium, here we go. I'm the Crab Pulsar, a young neutron star. I'm Calvera, an isolated neutron star that's far. My name's Vela X1, I'm a neutron star as well. Sirius B, that's me, a small white dwarf as you can tell. I'm EBLMJ0555-57AB. My name's TRAPPIST-1, an ultra cool red dwarf star in sight. I'm Proxima Centauri, a main sequence red dwarf star. I am your sun, a yellow dwarf that isn't too far. Alpha Centauri A is an orange star, you see. I am Sirius A main sequence star, that's me. We're all stars compared to each other by size. You can see a lot of us when you look into the night sky. We're all stars, our colors vary, you know. We're made mostly of hydrogen and helium, here we go. VFTS 352, contact binary 1 and 2, composed of 2 very hot, bright, massive stars that orbit each other, it's true. My name is Pollux, a red giant star here. Arcturus is a red giant star, I hope I made that clear. R136A1 is a Wolf Riot star thus far. I'm Aldebaran, a red giant star, that's me. Rigel is here, a blue-white supergiant you can see. I am Betelgeuse and I'm a red supergiant in class. VY Canis Majoris, a red hypergiant star with mass. I'm UI Scuti, the biggest red supergiant this far. Join us to sing the chorus, now get your head out of the stars. We're all stars compared to each other by size. You can see a lot of us when you look into the night sky. We're all stars, our colors vary, you know. We're made mostly of hydrogen and helium, here we go. We're all stars compared to each other by size. You can see a lot of us when you look into the night sky. We're all stars, our colors vary, you know. We're made mostly of hydrogen and helium, here we go. I am the Earth, the only planet with organic life. With 8.7 million species, we all fight to survive. You all live on me, so work like bees in a hive. And keep this planet really healthy so that we can 8.7 million species, we all fight to survive. You all live on me, so work like bees in a hive, and keep this planet really healthy so that we can all thrive. There are 12 different types of climates that exist on me. Moderate, polar, dry, and tropical are 4 groups you see. Then there is continental, it is the 5th category. One climate in no group is highland, way above the sea. I'm the 3rd planet from the sun, no one is denser than me. My axis tilted 23.5, yeah, that's my degree. 4.5 billion years ago is when I was born, you see. I am the Earth, the only planet with organic life. With 8.7 million species, we all fight to survive. You all live on me, so work like bees in a hive, and keep this planet really healthy so that we can all thrive. We're the 5 dwarf planets of the solar system in order from the sun. We're the 5 dwarf planets. According to the IAU, we're the only ones. My name is Ceres. I'm the smallest dwarf planet and the closest dwarf to the sun. I'm the largest object in the asteroid belt. Between Mars and Jupiter I run. Scientists think my bright spots are salty deposits made of sodium carbonate and ammonium chloride. I'm the only dwarf planet in the inner solar system, and my surface is completely dry. Hello, I'm Pluto, I used to be the 9th planet in the solar system planetary mix. But when Eris was discovered, it had 27% more mass. The IAU demoted me in 2006. I've since been a dwarf planet in your solar system and have 5 moons that orbit me so nice. I'm thought to have a rocky core which is surrounded by a mantle of water ice. We're the 5 dwarf planets of the solar system in order from the sun. We're the 5 dwarf planets. According to the IAU, we're the only ones.
I'm Haumea. I am a dwarf planet and was discovered in 2004 at the Palomar Observatory by astronomer Mike Brown. And I have 2 moons, now here's some more. My elongated shape is thought to be because the fast rotations that I make. Located in the Kuiper Belt outside the orbit of Neptune and the 3rd closest dwarf to the sun, for goodness sake. I'm Maki, the 4th dwarf planet from the sun, also located in the Kuiper Belt, you see. Discovered in 2005 by Mike Brown and his team at the Palomar Observatory. I have 1 provisional moon, its name is MK2. It's about 13,000 miles from me. I appear to be reddish brown in color, but I'm so far away that you can barely see. My name is Eris. I'm in the Kuiper Belt. I'm the 5th dwarf planet from the sun. I have 1 known moon, it's named Dysnomia. Its orbit lasts about 16 days on its run. I'm the most massive, but the 2nd largest dwarf planet after Pluto in the solar system.
If you wanna learn more about us individually, watch all of Kids Learning to Planet videos at once. We're the 5 dwarf planets of the solar system in order from the sun. We're the 5 dwarf planets. According to the IAU, we're the only ones. There's over 200 billion galaxies in the observable universe that we might see. Let's look at this galaxy size comparison from small to big. Of course, now here we come. I'm Segway 2, I'm a dwarf spheroidal galaxy situated in the constellation of Aries. My radius is 110.89 light years, they say. Discovered in 2009 by Sloan Digital Sky Survey. My name's Messier 32, a dwarf early type galaxy am I. 2.65 million light years from Earth I fly. I was discovered in the year of 1749. I am 6,500 light years across, and that's just fine. I'm small, Magellanic Cloud, or Nubicula Minor, a dwarf irregular galaxy, there's nothing finer. I'm near the Milky Way, but not a stone's toss. My diameter's about 7,000 light years across. I'm Triangulum, a spiral galaxy, you see. Sometimes I'm referred to as a pinwheel galaxy. I was discovered officially in 1764. I'm 50,000 light years across. This info is now yours. I'm the Whirlpool Galaxy, also called Messier 51. I'm a spiral galaxy, my arms reach out while I'm spun. I was first discovered in the year of 1773. 76,000 light years is the distance across me. I'm the Milky Way galaxy, a gigantic spiral disk with a bright central bulge that you can't miss. I'm 100,000 light years, your sun is 8 kpc from my center. On what is known as Orion's arm, it's a real bender. I'm Hoag's Object, a non-typical galaxy of the type known as a ring galaxy, as you can see. 121,000 light years across, bigger than the Milky Way, discovered by Arthur Hoag in 1958. There's over 200 billion galaxies in the observable universe that we might see. Let's look at this galaxy size comparison from small to big. Of course, now here we come. I'm the Cartwheel Galaxy, a lenticular and ring galaxy, discovered by Fritz Zwicky in 1941. I'm 150,000 light years across, my beauty is number one. I am M101, also known as the Pinwheel Galaxy, discovered by Pierre Michon in 1781, if you please. I'm 170,000 light years across, nearly twice the size of the Milky Way, now that's quite a toss. I'm the Andromeda Galaxy, a spiral galaxy, I say, in the nearest major galaxy to your Milky Way. My name stems from the constellation of Andromeda. I'm 220,000 light years across all BC, and yeah, I'm NGC 6872, also known as Condor Galaxy. I'm a large barred spiral galaxy, I'm sure you'd agree. Discovered in 1835 by John Herschel, the boss. I'm very large at 700,000 light years across. I'm the giant tadpole galaxy, a disrupted barred spiral, you see. I was discovered in the year of 2018. I'm 10 times the size of the Milky Way, that's extremely large, my friend. I'm 1 million light years long from end to end. I'm IC 1101, a supergiant elliptical galaxy. I'm one of the largest known galaxies found in your universe, you see. Discovered in the year of 1790 by John Herschel. 6 million light years across, with stars I am full. There's over 200 billion galaxies in the observable universe that we might see. Let's look at this galaxy size comparison from small to big. Of course, now here we come. We are some planets, all different in size. Here's our planetary size comparison for you live. We'll look at each planet, measured by their radius here. There are so many planets that will appear. I am Ceres, I am felt as the largest object in the asteroid belt. I am Orcus, to be direct.
I'm a trans-Neptunian object. I'm known as Sedna, if you can stand it. I'm a large minor planet. I am Quorer, you may respect, as a trans-Neptunian object. My name's kind of funny, it's Maki Maki. I am a dwarf planet, yeah, that's me. Haumea is my name, I'm sixth in line with fame. A dwarf planet, yeah, we're not all the same. My name is Eris, I am a dwarf planet, the most massive dwarf in your system yet. You know me as Pluto, I was a planet, but now dwarf you know. I hope the IAU puts me back as a planet though. Who's Kepler 37b? Wait a minute, that's me. An extrasolar planet that you now see. I am Mercury, the second hottest as I'm spun. I'm in your solar system, closest planet to your sun. Come visit this planet so far to learn all about Mars. I'm the 10th largest planet, but not really in charge. My name is Venus, for what that is worth. I'm almost the same size as your beautiful Earth. I'm the Earth on this planetary run. Please take care of me, I'm the planet you all live on. Proxima Centauri B, I'm the planet you see. An exoplanet in a habitable zone, you'd agree. Have you heard about me? Kepler 10b is my name. I have a rocky surface, I'm amazing, some do claim. My surface is a furnace, I'm Coro 7b. 489 light years from the Earth, that's me. Neptune centers Earth size, and my atmosphere's methane, hydrogen, and helium. And I'm the most distant from our burning sun. I'm Uranus, the planet 7th from the sun, yet I'm blue with 13 rings, I'm sure we have met. You know me as Saturn with rings, this is true. I have the most moons in the solar system, now 82. I'm Jupiter, the largest planet in the solar system. I am the 5th planet from the sun. I'm an extrasolar planet, this is 51 Pegasi b. Some think my atmosphere contains water that we may see. I am a planet, my name's Gliss 876d. An extrasolar planet up in this mix, that's me. I'm named HT 100,546b. I am designated the largest known planet you see. We are some planets, all different in size. Here's our planetary size comparison for you live. We'll look at each planet, measured by their radius here. There are so many planets that will appear. My name is Jupiter, the biggest planet you see. No planet in our solar system is bigger than me. My name is Jupiter, a windy planet I be. And I have 62 moons that rotate around me so free. The Romans gave me my name after their king of the gods, because my size is so massive in the sea of the stars. Callisto, Europa, Ganymede, and Io are my 4 biggest moons found by gas.
hot spot. It is a raging storm. Scientists think 400 years ago was when it took form. Hydrogen and helium make up most of my atmosphere. I am a gas giant and an impressive sphere. 3.13 is the amount of degrees that I tilt on my axis. Let's sing the chorus, please. My name is Jupiter, the biggest planet you see. No planet in our solar system is bigger than me. My name is Jupiter, a windy planet I be, and I have 62 moons that rotate around me so free. Here's a moon-sized comparison in our solar system. We're happy if you'd shed some light on us until we are done. We're measured by our radius, you'll hear in a bit. We'll also tell you the planet in which we orbit. My name is Tethys, I'm one of Saturn's 82 moons. My radius is 531 kilometers, it is true. I am Dion, I orbit Saturn, you do see. My radius is 561 kilometers, that is me. Ariel is my name, Uranus is what I orbit. My radius is 578 kilometers, I'm third on the list. Hi, I'm Umbriel, Uranus is where I'm from. My radius is 584 kilometers, I am spun. I'm the moon of Charon, I float in orbit Pluto. Radius is 606 kilometers, this I do know. I'm Iapetus, a moon of Saturn. Radius of 734 kilometers as I turn. Oberon is my name, outermost moon of Uranus. 761 kilometers is my radius. I am Rhea, Saturn's second largest moon. Radius of 763 kilometers, see you soon. Here's a moon-sized comparison in our solar system. We're happy if you'd shed some light on us until we are done. We're measured by our radius, you'll hear in a bit. We'll also tell you the planet in which we orbit. Not Titania, the largest moon of Uranus. 788 kilometers is my radius. The name is Triton, the largest moon of Neptune. I'm 1,353 kilometers in radius in this tune. Europa is frozen and the moon of Jupiter. My radius is 1,560 kilometers. I am the moon of the planet Earth. My radius is 1,737 kilometers for what it's worth. Hello, I'm Io, the strangest moon of Jupiter, with a radius of 1,821 kilometers. I'm Callisto, I orbit Jupiter, you see. My radius is 2,410 kilometers, that's all on me. Titan is my name, Saturn's my claim to fame. 2,574 kilometers is my radius I claim. I'm Ganymede, the largest moon in the solar system. Jupiter is what I orbit, yeah, that's where I'm from. My radius is 2,634 kilometers now. Let's listen to the chorus while the moons take a bow. Here's a moon-sized comparison in our solar system. We're happy if you'd shed some light on us until we are done. We're measured by our radius, you'll hear in a bit. We'll also tell you the planet in which we orbit. I am Saturn, the sixth planet from the sun. I'm known for my rings by everyone. I'm the second largest planet in our solar system. Please come sing along until my teachings are done. Out of my 62 moons, 53 are named. I am a gas giant, all astronomers claim. 36,184 is my radius in miles for you to explore. 10.44 meters, that's per second you drop. That's my gravity pulling towards my surface top. 10 hours and 39 minutes long is a day on my surface. Let's sing this song. I am Saturn, the sixth planet from the sun. I'm known for my rings by everyone. I'm the second largest planet in our solar system. Please come sing along I'm a supermassive black hole found in the center of almost all massive galaxies. I'm a supermassive black hole. There are theories of how I'm formed. Come and join me and see. There are three types of black holes according to theory: primordial, stellar, and supermassive like me. The primordial's a tiny hypothetical black hole. In 1974, Stephen Hawking theorized its role. Primordials were formed in the early universe, but we'll learn about this more when I teach that topic's course. On to the most common type called a stellar black hole. But let's first see why a star exists before it loses control. The pressure from nuclear fuel in the core pushes outward so greatly, while a force of equal power pushing in is caused by gravity. This equal pressure does create the star's main sequence stage. This means the star is stable in its present burning age. When stars with your sun's mass run out of nuclear fuel in its core, it becomes a red giant, then quietly becomes a white dwarf. But stars with 25 times the mass of your solar system sun runs out of nuclear fuel, its gravity crushes the core, and it becomes a stellar black hole. It's the most common type in the universe. After the chorus, I'll tell you how I'm created, of course. I'm a supermassive black hole found in the center of almost all massive galaxies. I'm a supermassive black hole. There are theories of how I'm formed. Come and join me and see. I'm a supermassive black hole, the third type of black hole seen, believed to be found in the center of any major galaxy. A black hole's a region of space where the force of gravity is so strong that nothing, not even light, can escape. You've learned this in this song. How I acquired my mass is still yet to be determined, and astronomers are still working on how I'm formed, that's certain. Some think I'm formed from the collapse of massive clouds of gas during the early stages of formation of galaxies with mass. My parts start with the accretion disk orbiting around me. It's superheated gas and dust swirling around the singularity. The singularity is the very center of a black hole you see, made up of matter collapsed into a region of infinite density. The event horizon's the radius around a singularity, where energy and matter cannot escape the black hole's gravity. The innermost stable orbit's the last place material orbits safely, without the risk of falling past the point of no return in me. A photon sphere's a location where gravity is so strong that light can travel in circles, and orbiting the black hole are photons. I feed on stars, dust, or gas, and produce jets of near light speed, blasting particles of radiation up from my poles, as you can see. These are relativistic jets, and my last part I'll talk about now. It's time to sing with me, do it loud without any doubt. I'm a supermassive black hole found in the center of almost all massive galaxies. I'm a supermassive black hole. There are theories of how I'm formed. Come and join me and see. We're astronomical objects brought to you here by size. Some within Neptune's orbit, others trans-Neptunian we fly. We're astronomical objects brought to you here by size. We all orbit the sun, that may come as some surprise.
I'm Phoebe, an irregular satellite of Saturn. I be my alternative name is Saturn 9, you can see. Discovered in 1899 by William Pickering. My diameter is 213 kilometers while I do my thing. I'm 10199 Caraclo, an asteroid with rings, the largest confirmed small body of the outer solar system. I sing. I'm possibly a dwarf planet with a measured diameter of 232 kilometers, I'm sure. I'm 38628, Hooyah, a minor planet in your system, or trans-Neptunian object is my technical term as I'm spun. You can find me in the Kuiper Belt in the outer solar system. My diameter is 406 kilometers, how fun. I'm 2018 VG18 of this I am sure. A trans-Neptunian object, don't leave, there is more. First observed in 2018 by 3 astronomers. 500 kilometers is my known diameter. My name is Vesta, I'm a minor planet, you now know. I'm one of the largest objects in the asteroid belt. I do show I'm probably the second largest asteroid after Ceres. I have a mean diameter of 525 kilometers, you see. I'm 2014 UZ224, a trans-Neptunian object and possibly a dwarf planet, but the IAU hasn't decided yet. Out in the Kuiper belt I was discovered, I am sure. 635 kilometers is my diameter. I'm 20,000 Varuna, a large trans-Neptunian object. In the Kuiper belt I dwell in possible dwarf, but not yet. My elongated shape is due to my rapid rotation. 668 kilometers is my diameter, well spun. I am Ceres, I am a dwarf planet. I'm the largest object in the main asteroid belt to orbit. I am too dim to be seen by the naked eye for sure. I am 946 kilometers in diameter. My name is Sedna, I am a minor planet on the run. I'm 3 times as far as Neptune from the sun. My surface is one of the reddest among the solar system objects. I'm 995 kilometers in diameter, glad we met. My name is Quorer, and I'm a dwarf planet candidate. But for now I'm a non-resident trans-Neptunian object. I reside in the Kuiper belt, it's so cold here, brr. And I'm 1110 kilometers in diameter. I'm 2007 OR10, that name it stood strong with the proposed name in 2019 of Gong Gong. My furthest distance is 9.4 billion miles from the sun. My diameter is 1230 kilometers as I run. I'm Maki, a minor planet I be. I'm perhaps the second largest object in the Kuiper belt you see. I was discovered in 2005 by a team led by Michael Brown, and currently 1430 kilometers in diameter, and I'm round. Almea is my name, I'm a dwarf planet by fame. Beyond Neptune's orbit you can find me with some aim. I'm the 3rd largest known trans-Neptunian object. I'm 1632 kilometers in diameter last I checked. My name is Ceres, I am a dwarf planet as well, and the 2nd largest dwarf planet in the solar system. How swell! Located beyond the Kuiper belt in a region called the scatter disk. My diameter in kilometers is 2326. I'm Pluto, I'm a big deal. As the largest dwarf planet, I used to be the 9th planet in the solar system till I quit. I am part of the cold and lonely Kuiper belt. My diameter is 2376 kilometers, so I tell. We're astronomical objects brought to you here by size. Some within Neptune's orbit, others trans-Neptunian we fly. We're astronomical objects brought to you here by size. We all orbit the sun, that may come as some surprise. I am the first planet from our sun you see. My name is Mercury, nothing orbits faster than me. The smallest planet with the 2nd hottest degree. My name is Mercury, no one is smaller than me. Messenger of the gods is what Mercury means. The Romans gave me my name, cause I'm the fastest they'd seen. A bit bigger I be than the Earth's moon that you see. To fill the Earth one time, it would take 18 of me. I am the first planet from our sun that beams, but I'm the 2nd hottest. I can reach 800 degrees. 88 Earth days is the amount that I take to orbit our sun once. That makes 1 year on me. I am the first planet from our sun you see. My name is Mercury, nothing orbits faster than me. The smallest planet with the 2nd hottest degree. My name is Mercury, no one is smaller than me. 59 Earth days equals 1 day on me. My surface is made of stone, covered in craters you see. Oxygen, sodium, hydrogen, helium, and potassium make up my exosphere. I have no moons and I have no rings.
rings, but I'm the second densest planet amongst other things. I am the first planet from our sun, you see. My name is Mercury, nothing orbits faster than me. The smallest planet with the second hottest degree. My name is Mercury, no one is smaller than me.
Check out the new KLT Geography channel with new videos every Saturday. This is a solar expedition on renewable energy. We'll see how solar panel cells produce free electricity. Our sun's a nuclear reactor shooting photons at us for free. Let's harness this power through silicon into batteries. What is solar power? It's the conversion of energy from our sunlight into electricity. Our sun's a natural nuclear reactor, you should know. It's the most abundant energy resource on Earth, I'll show. Now what's a photon? They're light particles produced by the sun. They're made by nuclear fusion, shot into space in all directions. It takes 8 minutes and 20 seconds for a photon to run before it reaches our Earth from the surface of our sun. Photons are made of electromagnetic radiation. They're tiny packets of energy I convert into electricity for fun. On a photovoltaic cell, a solar cell, you see. I'm like an electrical leaf, I use the sun to produce energy. Solar panels are made up of me, small solar cells. These cells are made from silicon, of this I will tell. Silicon is a semiconductor for what it is worth, and one of the most abundant elements on the planet Earth. In a solar cell there are 3 layers shown right here. I will tell you about each layer as they appear. The thin top layer does contain silicon, you should know, and a tiny amount of an element called phosphorus. I show the phosphorus has more electrons than the silicon does. That means there are more electrons, making this area more conductive. This layer with the phosphorus gives electrons more room to roam, which makes it negatively charged, so it's called the N-type as shown. The bottom layer contains silicon and an element called boron, which has fewer electrons than the surrounding silicon. Because of the fewer electrons, this layer is positively charged. That's why it's called the P-type layer, as shown at large. My middle layer is called the PN junction. Soon we'll see what happens when photons hit me from the sun. Silicon atoms are connected to its neighbor by 4 strong bonds. This keeps the electrons in place, in which I'm not so fond. When a photon shoots into a solar cell with enough energy, it can knock off an electron from its bond, leaving a hole. You see, the negatively charged electron and positively charged hole are now free to roam around, but there's only one way each can go because of the electrical field in the p-n junction. The electron's drawn to the n-type and the hole is drawn to the p-type. They run. The mobile electrons are collected by metal strips at the top of the solar cell. From there they flow to the external circuit to power a light bulb, I tell. They flow through and return to the conductive aluminum sheet on my back. Then they return from where they came from with no waste, that's a fact. A single solar panel has many solar cells to create more energy in a small space to keep your home running well. When too much energy is produced, it gets sent back to the electrical grid to help produce more electricity for some other kid. The sun produces more energy each hour than we will ever need. There's so many ways that we can create renewable energy. This is a solar expedition on renewable energy. We'll see how solar panel cells produce free electricity. Our sun's a nuclear reactor shooting photons at us for free. Let's harness this power through silicon into batteries. What's the Eiffel Tower? It's a wrought iron lattice tower in Paris, France. When you visit me, take the elevator to the top floor if you have the chance. The Eiffel Tower was the main exhibit at the World's Fair in 1889.
1889, built to commemorate the centennial of the French Revolution. At that time, I was named after this engineer, Gustav Eiffel, this man right here. His company designed and built the tower in 1887, yeah, that's the year. It was built to commemorate the 100th anniversary of the French Revolution. It was finished in 1889 for the entrance of the World's Fair institution. I'm 1,063 feet tall from my base to my antenna tip. Almost 7 million people visit me annually, come take the trip. My official color is Eiffel Tower brown. I'm painted every 7 years with 60 tons of paint, so my raw iron doesn't rust, that is the fear. The weight of my metal frame is roughly 7,300 tons of fun. Add the weight of my lift shops and antenna and I'm 10,100 tons. I'm located in Champtien-Mas, Paris, France. Don't you know? After this chorus plays out, I'll have more to show. What's the Eiffel Tower? It's a wrought iron lattice tower in Paris, France. When you visit me, take the elevator to the top floor if you have the chance. The Eiffel Tower was the main exhibit at the World's Fair in 1889, built to commemorate the centennial of the French Revolution. At that time, did you know Gustav Eiffel was the second designer you see for the internal structural elements of the Statue of Liberty? Gustav Eiffel built an office at the top of the Eiffel Tower, where he entertained guests like Thomas Edison and other people of great power. Did you know the Eiffel Tower moves when the wind is bad enough and the sun can expand and contract its iron up to 7 inches, but it's tough. Below my salt pillar there is a military bunker, but it's kept secret to the public to keep the visits to a shorter number. I have a small post office located on my first floor, you should know. If you send a postcard, it will be delivered with a unique postmark it will show. Come visit me, I am the Eiffel Tower in France. Please sing this chorus with me as I do my dance. What's the Eiffel Tower? It's a wrought iron lattice tower in Paris, France. When you visit me, take the elevator to the top floor if you have the chance. The Eiffel Tower was the main exhibit at the World's Fair in 1889, built to commemorate the centennial of the French Revolution. At that time,